Okay, this will be the video recording for the Chapter 5 AP Statistics lessons. And I'm going to go ahead and start by sharing just my entire screen here because I'm going to go back and forth between the presentation and a calculator. So I'll go ahead and have that on the screen as well. All right, for this one, a lot of the things that are in the textbook in Chapter 5 are actually we covered in the last lessons in Chapter 4, because a lot of that makes sense to talk about, how to calculate. 5 is really about how to calculate the numerical values, and 4 is more about the display part. So I think you can't really do the displays or descriptions without having the numbers. So we kind of sort of teach it together, and we're going to take the quiz for Chapter 4 and Chapter 5 at the same time, even though they have separate practice packets. So in Chapter 5 here, I'm going to kind of expand on some of the things that we already covered in Chapter 4. So to begin with, let's say that we had a small data set here, like 5, 10, 7, 4, and 8. And if I wanted to kind of make a little graph of that on a number line here, I could have, a number line and just have, let's see, values from, let's just say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as far as, let's just use a dot plot. So we have a 5, we have a 10, we have a 7, we have a 4, and we have an 8. Okay, I want us to get an intuitive understanding, a better intuitive understanding of what standard deviation means, because that's such an important thing and we use it so frequently throughout the course. So we could put this into a list in the calculator and use the one variable statistics to be able to calculate the standard deviation and the mean. And we already know how to do that. In fact, maybe just a quick review. So if I were to go to Stat and edit, so you already have some data in here from before. So one thing you need to know is how to clear out lists. So there's two ways to do that. One way is you can go up and highlight the name of the list and then hit the clear button and then the enter button, and that will clear the list. Or if you're back at the command line and you want to clear all the lists all at once, if you're using a bunch of lists, you can go second and then the plus key to get to the memory menu, and option number 4 is clear all lists. And when you run that, it'll just clear all the lists all at once. So somehow you would need to clear out list 1, and then we could just enter this data in: 5, 10, 7, 4, and 8. Okay, and if I wanted to get statistics on it, quit out to the command line, and then it goes stat over here, 1 to 1 variable statistics on list 1, and we would get that the mean at the top here, the mean is, that should be x bar, is 6.8. And then the standard deviation, we're going to use this S value here. There's two values, S and sigma. Later we'll talk about the difference and later in the course, and we'll talk about the rare times when we would use this. But usually we're going to use this S value. You can just think of it as S is the standard deviation for a sample, so 2.387447. Okay, and the formula for this is the standard deviation is the square root of what we call the variance. And the variance is the sum of all the distance that the data is from the mean squared, summed up and then divided by 1 less than the total, which is kind of like the average distance squared. So I just wanted to kind of visually picture what's going on here. Imagine that we had, we've got this data, and the mean of this data is 6.8, so almost at 7. In fact, the mean is right there. Okay. So then I'm going to go ahead and just kind of draw in how far away is each data point from the mean. And I'm just going to round it to the nearest value. This data point is only 0.2 away. So basically this data is 0 away from the mean, right? This data is about 1 away from the mean, and this data is 1, 2, 3 away from the mean. In other words, if I look at the distances to these pieces of data, they're almost 0, about 1, and about 3. Right? This data is -2 from the mean, but if I just took the square of something, I'm going to end up throwing away the distance. So this one's 2 away from the mean, and this one is 1, 2, 3 away from the mean. Okay. Okay, so the first thing that the variance does is it takes those distances. So you can think of the thing inside this parenthesis is really these green numbers, right? And they're actually, the ones over here are negative. We square them. Okay, and then we're going to add them up and take the square root again, so we're back to having the distances except just the positive distances. So really what this structure is doing is squaring them, adding them up and dividing by the number of elements to take the average and then undoing the square. So it ends up representing the average distance that data points are from the mean. Points are from the mean. Okay, so what I mean is, if you were to take these distances, 3, 2, 0, 1, and 3, those are all the distances that data is from the mean, right? And then I just took those as numbers, 3, 2, 0, 1, 3, and I averaged those up, and I found the average of these. That average would be the standard deviation, which turns out to be about 2.4, approximately 2.4. And what that's saying is, not all of this data is at the measure of center, right? It's on average about 2.5 away. So you can kind of go a distance 2.5 this way and a distance 2.5 this way. And that kind of gives me an average distance that I am away from the mean. So I am an average of 2.4 and an average of 2.4 above and below that mean. Not sure what that letter got in there. Okay, so that's really what the standard deviation means. I think I want to develop an intuitive understanding of it. And what that means is, if you have a set of data, let's say you have a set of data that its shape looks like this. Maybe its mean is here, right? And maybe if you kind of went out to the bulk of the data here, maybe this distance is 3. And this distance is 3, and this is centered at a value of 25, right? Then you would say the standard deviation, S, is 3, right? That means that on average, the distance is 3 on either side. On the other hand, if you had that same mean at 25, right, but you had data that was really closely grouped in here, where, like, if you went partway through the data here, you would be only 1 away and 1 away, then the standard deviation over here would be 2. So this standard deviation is a measurement of how widely dispersed the data is around the mean, right? So if it's a small number, it means small s means the data is tightly grouped. Okay? And if you have larger s, it means the data is spread out. So it's important to have that general basic understanding that bigger standard deviations mean wide dispersion, and small standard deviations means narrow dispersion, or narrow spreading out. Okay, that's the first thing I wanted to cover. The second thing is, I wanted to talk about how to use the calculator. We know that we just did this. We can run one variable stats, and when we do that, when we run our statistics function, we put the list that we're running the data on here, and we keep the frequency list blank. Okay, but we're going to show now how you would use this frequency list. Let's say we had a really big set of data like this, okay, but it had a whole lot of repeats in it, like we had 10 2s, and we had 11 5s, and we had 12 8s, and we had 17 13s, and 11 14s, and 6 15s, and 3 16s. Okay, so if we had multiple repeats, so these are the values of the data, right? And then we could make a second column that is the frequencies. In other words, almost like if you did a bar chart of these values, there'd be 2 10s and 5 11s. These would be like the heights of the bars. Then you can actually, rather than type in literally 10 2s and then 11 5s and then 8 12s, or 8 12s or whatever in the, I guess actually this would be the reverse. I have this reverse. Let me fix that. So what I'm really saying is that there's 2 10s, but there's 5 11s, and then there are 8 12s, and so on, right? So I had those reversed, right? There's 2 10s, but there's 5 11s, but there's 8 12s. So this is the data value itself, and this over here in the frequency column is how many times that's replicated. So what you can do in a calculator is, if you have data kind of listed that way, then you can use 2 lists, one for the data values, like let me enter this in and you can do this as well. The data values are 10, 11, 12, 13, 14, 15, and 16, but we have 2 10s, 5 11s, 8 12s, 17 13s, 11 14s, 6 15s, and 3 16s. You can put directly across from that in list 2 the frequencies of each of those values. Okay, now when you do that, you can run all the normal statistics we would run, but you have to indicate that the frequencies are in list 2. Let me show you the 3 ways we might do that. The most common one will be if we want to calculate statistics, like if we want to do one variable statistics. Even though there's 2 columns here, there's still only one variable. So we don't select 2 variable stats, we use one variable stats, and we still select list 1 for the list, but instead of leaving frequency list blank, we say second 2 to make that say look in list 2 to get the frequencies of those. And then when we hit calculate, it's going to be the same as if we had this entire set of data. And so you notice how it says that there's actually 52 elements of data in here. And then we can get the mean, standard deviation, which is the SX value. We can scroll down and get the 5-number summary, the min, the max, the median, and first and third quartiles. Okay, so that's the first thing. You can also use this when you do histograms. So if you go second y equals, go into stats plot menu 1 and do a histogram, there's a spot to do that, right? There's X list, which is the list of the data, so list 1. And normally, although it's blank in the other screen, here you would want the number 1 here for frequencies. You can tell it to get the frequencies from a list, second 2 to get list 2. And then when we say zoom 9, we're going to get a histogram, but that's a histogram of 56 pieces of data. Like if I put a trace on here, right, you can see that from 10 to 10.5, there's 2 elements there, there's 5 there, and so on, right? So you can use that. You just got to be careful that if you've done that, then the next time you go in here, it's going to remember that, right? So you're going to have to go back and manually change this back to 1 if you only have the data in a single list. The way you do that is you delete it first, and then you go back and type, right, you delete it first, and then you go back and type 1. Okay, and then same thing here when you do statistics, you can this will still show that. So if you want to go back to having only data in a single list, you have to delete that and leave it blank. Okay, all right, so I just wanted to show you this way to use 2 columns instead of 1 to use your calculator. And the notes has the steps for using 2 elements here. If you have a TI-83, then when you do one variable stats, you won't get this entry screen. It'll just put this right on the command line, one variable stats. And so you need to know to put second L1 to enter this manually. And then if you are using a second list, you press the comma key, which is above the 7, and then you say second 2 to enter L2. So you can specify, and by default, the first thing you put in is where the data values are, and the second thing is the frequencies of those data values. All right. Some other general comments here. One is that whenever we're describing distributions, it's okay to say something symmetrical. It's okay to say it's mound-shaped if it kind of looks, you know, like this, right? But we really should avoid using the word normal, because normal is a very specific shape. It corresponds to what we call a Gaussian distribution. And in chapter 6, we're going to talk about what you have to do to be able to show that something is normal. And so for now, I'd like for us to avoid using the word normal shaped, okay? Just use mound shaped or symmetrical. Okay, and I want to show you one last thing, which is a special kind of a diagram that does show up in chapter 5. It's called a relative frequency histogram, but it also goes by this name, Ogive. Okay, kind of a strange diagram. So let's take a histogram. So we had some data that we know from 0 to 9, there was 2 values. From 10 to 19, there was 5 values. So this histogram represents this data. And then what you could do is you could figure out the cumulative frequency. So the cumulative frequency means how is the frequency accumulating. So let's say we've seen, by the time we get to here in the value, right, we've seen a total of 2 pieces of data, right? And then in this bar, there's 5, which means by the time we get to here, we've actually seen a cumulative total of 7 pieces of data, right? Okay, and then let's see. Yeah, by the time we get to this value out here, to 30, then there's another 12 in here. So that means we have 2 plus 5 is 7. So 17, 19, we've seen 19 pieces of data. And by the time we get to here, that extra 6 brings it up to 25, the cumulative total, and then the 3 here bring it up to 28. So there's 28 pieces of data, but we can kind of show how much of it has accumulated by the time we get to each of the edges of these bins, right? And if you think of that in terms of percentage, right, we're saying that right here by here, if you take the count of 2 divided by the 28, we've seen 7% of the data by the time we get here, right? 7% of the data. By the time we get here, we've seen a total of 18% of the data. By the time we get to here, we've seen 43% of the data values. By the time we get here, we've seen a total of, oh, that's wrong. We have to use the cumulative total. So let me go to this screen. So let me start over. When we start at 0, we've seen none of the data yet, right? But by the time we get to 10, by the time we get to the end of this, we've seen 7% of the data. By the time we get to 20, we've seen that 7% plus the 18% in this bar. We've seen a cumulative total of 25% of the data at that point. Right, that's actually means Q1 would be around 20. And then by the time we get to 30, we've seen a cumulative total of 68% of the data. And by the time we get to 40, we've seen a cumulative total of 89% of the data. And by the time we get to 50, we've seen all of the data. Okay, so if we want to show how the data is accumulating on its way to 100%, we can draw this graph down here. This is called an ogive. Okay, or a cumulative relative frequency histogram. So just like we would for a data value for a histogram or anything like that, we have the value of the variables this way, and then this axis shows the cumulative percentage adding up on its way to 100%. So it starts at 0%. By the time it gets to here, we've seen 7% of the data, so up 7%. By the time we get to 20, it's up to 25%. By the time it's 30, it's up to 68% and so on. And finally, the last point will be at 100%. All right. So the use of this, there's a couple uses for this, but the main use for it is if you have data that's presented this way, you can quickly figure out where things like the median and the quartiles are. So we know that the median is when 50% of the data, there's some value here where 50% of the data is below that. Right, because it's the middle data point. So if you go on this axis to 50% and you scan across here and see where that occurs on this line, you can drop down here, and that's telling me that the median is at roughly 27. Okay, even without having the data to plug in a calculator, I can see from the graph that roughly the median is there. Right, and when it comes to the quartiles, right, I could use same tactic. The quartile 1 is where 25% of the data has occurred. So that's going to be, this is where Q1 is at 20. And then the 75th percentile, so if I kind of go across here, that implies that Q3 is maybe 36, something like that. So you can use this to be able to quickly get the 5-number summary, the min, the max, well, the max and min don't show up because it could be somewhere in here, but you can get the Q1 and Q3 and median from an ogive, which is also called a cumulative relative frequency histogram. Okay. All right, and you can also get an idea of the shape from looking at an ogive. So if you have symmetrical data like this that's mound-shaped, it will be reasonably linear with just a little slight S-curve like that, okay? On the other hand, if you have skewed left data, what's going to happen is it's going to take quite a ways into the data values before you get to the 50% point. So it'll stay low as percentage and then ramp up rapidly. So if you have an ogive that's curved like this, it corresponds to skewed left data. And the reverse is true. If you have most of your data in the beginning, then it's going to jump up quickly in percentage as we go across the data, and then it'll slowly reach that. So this is indicative of skewed right data. So you can get another way to kind of quickly get an idea of shape if they give you information like an ogive of the data. All right, so that's it for chapter 5. Like I said, we covered a lot of the stuff that's in the textbook, like, you know, what standard deviation is, computing mean and median, the fact that there some statistics are resistant. All of that stuff was covered more in the chapter 4 lessons, but this is all we need to finish off chapter 5.